Hey guys, so in today's video we're going to discuss a very important question. I get asked, so many people on LinkedIn, Instagram and other social sites, they ask me these questions. So you're interested in physics and math, or maybe you're not interested but you just want to know whether physics or math is your cup of tea, right? So where to start or how to start. So I'm very interested in physics now, and I wish to pursue physics as my profession, as my career in the future. But a few years back I simply hated physics. Believe it or not, I just hated physics, math and these kind of subjects. I just hated science actually. So why did and today I am a physics editor in an international journal. I have published some physics articles with the journal, and I'm about to publish a popular science book on physics, being a school student. So it's nothing like, it's not a great achievement or something. Even you can do that. But the thing is that, why did I become so much interested in physics suddenly, all of a sudden? My answer is by reading popular science books. Popular science books, many people see, if you try to read your textbooks, try to measure your interest in a subject only by your school textbooks, then that is not the correct way, because school textbooks, they offer you very limited scope, very limited, like a limited perspective. If you really want to find out whether a career in physics would be right for you, then a career in physics doesn't mean what you're learning in school, right? Then you need to learn about what physicists are doing today, like advanced in the sense, I'm not asking you to start solving quantum mechanics, QFT, quantum field theory problems when you're in high school, obviously not. But if you do a bit of a reading, popular science means what? A general book. Anyone can read that book. There is no technical equations or anything in the book. So we do a bit of a general reading about what physicists are doing today, about particle physics, quantum mechanics and these things. Then you can understand whether these things are interesting you, whether you in the future will be able to do a research in these fields or not, right? So reading popular science books is very important. So that's the way. Now, if you ask me to suggest some popular science books, so for physics, I would suggest, number one, I would suggest books by Michio Kaku. M-I-C-H-I-O-K-A-K-U. Michio Kaku is a physicist, and a science popularizer of science. So he's a very good author, and he has a lot of popular science books on physics out in the market. So, and those books, I would say, they're very, very like interesting books, and they would definitely spark. Actually, my interest in physics sparked by reading his books only. That's why I'm saying his name at the first. So, how to choose from, because he has a lot of books, how to choose from between these different books. So you can try these books by Michio Kaku. You can try Hyperspace. This is a very good book. Space-Time Odyssey Through Parallel Universes, Time Warps, and the 10th Dimension. So this book basically will give you some, introduction in the sense, some very basic idea about string theory, dimensions, higher dimensions, Kaluza-Klein concept. Then, mainly string theory, quantum mechanics, the journey of physics, even some relativity is there. Hyperspace in the sense, then what will be there in the future, the fate of the universe and all these things. It's a very good combination. Very good book, I would say. Very good book. Next is this book is again a very good book, Beyond Einstein. Beyond Einstein, The Cosmic Quest for the Theory of the Universe, the final theory, unified field theory of everything. So in this book, it's mainly an introduction to string theory, mainly string theory, supersymmetry, and some applications like, other dimensions, cosmic strings, dark matter, before the Big Bang, pre-Big Bang physics and these things. So this is also a very interesting book. Some parts are common obviously in all Michio Kaku books, but obviously this is a very interesting book and a book by itself, a very great book. Next, if you want to read something like, you can try these books by Michio Kaku. Parallel Worlds. This is a very good book, Parallel Worlds. The Science of Alternate Universes and Future in the Cosmos. So this is mainly cosmology. This book is mainly cosmology, but not only cosmology. It's let me tell you from the contents. Okay. So first of all, the universe, the multiverse, black holes, and string theory, and many things are discussed. So you can see baby pictures of the universe, the paradoxical universe, the Big Bang, inflection and parallel universes, dimensional portals and time travel, parallel quantum universes, M theory, the mother of all strings, a designer universe, searching for echoes from the 11th dimension, end of everything, escaping the universe, beyond the multiverse. Now this book is somewhat common with Hyperspace. I would say somewhat common, but Hyperspace focuses more on the dimension, string theory and those things. But this book focuses more on cosmology. But so you can try this out definitely. Next, is your Physics of the Impossible. This is another great book by Michio Kaku, but this book is not exactly like Physics of the Impossible. It's a scientific exploration of the world of phasors, force fields, teleportation and time travel. So if you want to learn some interesting concepts in physics and whether they're possible in the like sci-fi stuff, you understand, right? Sci-fi stuff. So whether they're possible in the future, what is the feasibility of these technologies? So then this book will be obviously definitely be interesting, but otherwise not. Like force fields, invisibility, whether that will be possible, psychokinesis, robots, faster than light travel, time travel, perpetual motion machines, precognition. Okay, these things mainly. Now, there is one more popular book, not by Michio Kaku, by Stephen Hawking. Obviously, you have heard of this book. A Brief History of Time, From the Big Bang to Black Holes. So, this book, I would say, see, this book, if you have read Michio Kaku books, then this book you will not find much new stuff in this book. I'm not criticizing the book, by the way. This is obviously like a timeless book. But yeah, and obviously Stephen Hawking is a great author, great physicist. But this book is basically just give you a basic idea about physics, about cosmology and black holes. Basic idea. Cosmology, black hole, time and unification. So yeah, you can try it out obviously. But if you have read many of Michio Kaku's book, I think this book is not absolutely essential. Okay, that's it. Now there are a lot of other popular science books on physics by other authors which I think you should check out. Right. For instance, this book, one of my personal favorites. Dreams of a Final Theory by Steven Weinberg. I actually had a Gmail conversation with this author, Steven Weinberg. He's a Nobel Prize winning physicist, and so this book is really about the book we had a conversation. So this book is really extremely great book, and this book is it's mainly about a final theory in physics. Will we ever discover a final theory in physics? What would a final theory mean to us? Like, what do you even mean by final theory? The unified field theory, and there are a lot of technical content on quantum, on reductionism. Sorry, not technical content. I'm actually I apologize for this. Not technical content. These things like reductionism, the basic philosophy of science, then quantum mechanics, tales of theory and experiment, then beauty in physics, like symmetry and these things. Then against philosophy. Arguments are also there. So overall, this is a very great combination of stuff in physics, a final theory in physics. But yeah, this is not exactly a treatment of the journey of physics from classical physics to relativistic physics to quantum physics to modern physics. Not like that. It's mainly about, as the name suggests, dreams of a final theory. It's mainly about a final theory, like a final theory, is it possible or not? But God and many other philosophical arguments are also there. So overall, this is a very, very great book, very great read. I would definitely ask you to go for this book. And if you're interested in any particular area of physics, like maybe relativity, then obviously you have this very famous book written by the master himself, Albert Einstein, Relativity, the Special and the General Theory. Now this book, there is some technical content and it's not written in an interesting manner like popular science books. So you may find the book to be a bit boring. I'm telling it as a warning. So there are other good books on relativity, but yeah, and if you are particularly interested in quantum mechanics, you can try Leonard Susskind's book, Quantum Mechanics, the Theoretical Minimum. It's a very famous book. I don't have the book currently right now, so I cannot show you, but a person borrowed it actually from me. It's called Quantum Mechanics, the Theoretical Minimum by Leonard Susskind. Then there is this very great best-selling book, The Elegant Universe by Brian Greene. This is again a very, very good book of physics, a popular science book on physics. So this book will actually this treats the journey. It's it tells you the journey of physics. From relativity, quantum mechanics, string theory, and many other interesting things, black holes, etc. discussed. And this book actually treats each topic with enough detail, with enough rigor, while keeping the book simple, while keeping the book, not going too much deep into the technicalities. It's a very great read. It's a bit long book, actually a bit fat book, as you can see. It's a huge, lengthy book, but it's a very good book overall. It's a great book. The Elegant Universe by Brian Greene. The Elegant Universe, Superstrings, Hidden Dimensions, and the Quest for the Ultimate Theory. Now, some books to avoid. If you are looking for popular science books, if you are looking for books to understand whether physics is your cup of tea, then see these books you see, introducing series, Introducing Relativity, a graphic guide. So introducing relativity, and these books are written in like, these cartoons are there, written in a funny way. I'm not criticizing this book, it's written in a funny way. So you may think that this will just introduce you to relativity in a very easy way, but actually the Einstein field equations are given in this book. So regional explanation, mathematical explanation is not given. So if you read this book, you will not understand the mathematics of relativity, but the mathematics is given, only the mathematics, not the explanation. So you'll feel frustrated. So that's why I ask you not to go with these books. Like I have this book, but these books you can try also. But like I personally like this book, not relativity, but this book is a very good one, Introducing Quantum Theory, a graphic guide. But again, a regional description is not possible. But yeah, the subjects are treated in a funny manner. So like you can see, it's an innovative idea actually. These kind of books, introducing books. So you can try them out, but I would not recommend them. Okay, personally. Introducing Time, a graphic guide. Next, these books actually this book you see, String Theory Demystified. So I'm very interested in string theory, but I'm a high school student, so obviously I don't know the required mathematical apparatus, the mathematical framework needed to learn string theory. So I bought this book because the name was String Theory Demystified, but actually this is a highly advanced book. You see these calculations and equations are there. It's a highly advanced book. So at this level, like if you are hoping to find some books which will help you understand whether physics is your cup of tea or not, I would say absolutely not to go with these demystified books. This is not for you if that is your purpose. Though the name, see, hard stuff made easy. The name seems that by reading the name you've seen that this is a very basic treatment of string theory, but it's not that. It's a very advanced book. So I would ask you not to go with these kind of books. Now personally I would also ask you to go with these kind of books. Chaos, James Gleick, Chaos, the amazing science of the unpredictable. Chaos making a new science. So chaos theory is a branch of physics you can say, and chaos theory is a very, very interesting field. So you can just try reading this book. Very interesting book this. You can just try reading this book. Because chaos theory, it's a like relatively new field, and there is a lot of scope in this field. That's why I'm telling. And if you are interested in, reading about the philosophy of physics, philosophy of quantum mechanics, the scientist's philosophy, then this is a very good book to try. Einstein's Dice and Schrodinger's Cat. How two great minds battled quantum randomness to create a unified theory of physics. A very good book. And if you're interested in interdisciplinary subjects, actually not exactly interdisciplinary subjects, but if you are interested in consciousness and these things, and philosophy, then I would suggest this book by Michio Kaku, The Future of the Mind. Because this book, see, he has treated the subject of consciousness, neuroscience, etc. from the perspective of physics. And he's also given some notes on quantum physics and everything. So this is a very good book to try out, obviously. But if you're only looking for physics book and if you've already checked out Michio Kaku's other books, then this book will not be of much interest to you. The Future of the Mind. Next, mathematics. So if you want to explore whether mathematics is a cup of tea or not. So, by the way, before we start mathematics, you can also, if you are interested in the philosophy of physics, metaphysics, there are a very short introduction. These kind of books, you see, there are a very short introduction by Oxford University Press. You can see here Oxford University Press. So this is a series. So this series offers some interesting books. For instance, this is the metaphysics. So books come about metaphysics, philosophy of science, the meaning of life, consciousness, physics. So you can try these books. That's a short suggestion from my side. Now, if you are interested in mathematics, if you want to understand whether mathematics is a cup of tea or not, and if you want to start reading some popular science books in mathematics, I don't have many suggestions because I have not explored mathematics, popular science books on mathematics much. I have only explored physics. But I have three very, very good suggestions for you. Number one, Max Tegmark. This is again a physics book actually, Our Mathematical Universe. So this book, the first part is, most of the part it's mainly physics, it's mainly physics, cosmology and everything. But the last part is a bit mathematical and philosophical. So you can try this book obviously. Our Mathematical Universe, My Quest for the Ultimate Nature of Reality, Max Tegmark. Next, this is a very, very great book. How Not to Be Wrong, The Hidden Maths of Everyday Life by Jordan Ellenberg. Now this is it's one of my favorite, this is a very, very great book. This book will actually give you examples of how we use mathematics in our daily life and some very interesting examples, some very good illustrations are there in this book. like many illustrations are there. It's written in a very good style. It's easy to read and easy to like enjoyable book. It's a very good book. How not to be wrong. The hidden maths of everyday life. Last but not the least, if you want to do research in math, I mean, if you are thinking of making mathematics your career, then you can try reading this book. This is a sort of popular science book only. Yeah, this book, Fermat's Last Theorem by Simon Singh. Fermat's Last Theorem. So in this book, the author has described how, you see this book, Fermat's Last Theorem, the author has described how a great mathematical riddle has been solved. So you'll get an idea of what mathematics research is like, what mathematicians are doing and these things. So that will give you an idea and you can understand whether mathematics is a cup of tea or not. So I hope this video was helpful to all physics and math aspirants out there. So thank you for watching. Thank you very much.